Okay, so we're starting section 2-4 for people at home. I'm recording right now. Cross-off problems 5 through 14. We're not going to do those, okay? So it's going to start out with just doing functions here, and it starts off with really basic stuff that you've done back in algebra 2, and then it gets a little bit tougher, okay? So let's look at question number 1. Just dealing with functions. They give us functions. They ask us for value of the function at different points. So, and again, this is section 2-4. We are not doing section 2-3, so we've only done sections 2.2 and 2.4. We did not do 2.1 or 2.3. Okay? So they give us f of x on number 1. It's negative x squared minus x minus 4. And they ask us to find f of three values, f of negative 2, f of 0, and f of 4. So, quite simply, you guys know this. We're going to plug in negative 2, get an answer, plug in 0, get a different answer, plug in 4, get a different answer. And when you plug things in, it's a good idea to always put them in parentheses, okay? If you don't put them in parentheses, quite often you will get the wrong answer. So, we have a negative, write down the negative, then I see an x, so I put in parentheses negative 2 squared, minus, oh, there's an x, put in parentheses negative 2, take away 4. So, we're going to square negative 2. Negative 2 squared is negative 2 times negative 2, which is positive 4. But there's a negative out here, which makes it negative 4. And then we have negative 2, which is positive 2. And then we have a minus 4 at the end. So this is positive 4. That makes it negative 4. Negative 4 plus 2 minus 4. Negative 4 and positive 2 is negative 2. Negative 2 minus 4 more is negative 6. Okay, a lot of negatives in there. I mean, all we're doing is plugging in a value and getting and simplifying it. There's a lot of negatives, though, you got to watch. We plug in 0. Negative parentheses 0 squared minus parentheses 0 minus 4. Well, this is just 0 squared, which is 0. The opposite of 0 is still 0. Minus 0 is 0. Minus 4. I'm not going to show my work on that one. Everything goes away except for the negative 4. Then we plug in 4. Negative parentheses 4 squared minus parentheses 4. Take away 4. Again, we're squaring 4, which is 16, but that makes it negative 16. Minus 4, minus 4 more. Negative 16 minus 4 is negative 20. Take away 4 more is negative 24. Okay, so I mean, like I say, these are just a lot of negatives in there, so it's a little tricky, but we're just plugging in values that they give us a function asking for different values. Okay. Number 3, different functions, same type thing. This time the function is f of x equals radical x minus 4 minus 3x. And they want 4, 8, and 13. Find f of 4, 8, and 13. f of 4, f of 8, and f of 13. So if we plug in 4, we're going to have 4 minus 4 minus 3 times 4. Okay, I'm not going to show all my steps on this one. You should be able to do a lot of this in your head. 4 minus 4 is 0, and the square root of 0 is 0. So that's gone. You're left with negative 3 times 4. So that's just negative 12. Plug in 4. 4 minus 4 is 0. Square root of 0 is 0. It's gone. Negative 3 times 4. Plug in 8. Radical 8 minus 4 minus 3 times 4. Again, a lot of this you can do.
8.
I'm sorry?
3 times 8.
Oh, yes. Thank you very, very much. Yes. Plugging in 8, not 4. Good. 8 minus 4 is 4. Radical 4 is 2. Minus 3 times 8 is 24. 2 minus 24 is negative 22. Then we plug in 13. Radical 13 minus 4 minus 3 times 13. 13 minus 4 is 9. Radical 9 is 3. Minus 3 times 13 is 39. 3 minus 39 is negative 36. Okay, so nothing new here at all. Just giving you a function, value of the function, plug it in. Okay, 15. Let's do a very quick, easy one. It's been a while since we talked about this. So is that a function? When I look at number 15, is that a function if I look at the graph? You guys remember how you can tell if a graph's a function just by looking at it? That one definitely is. It passes a certain test. Vertical line test, okay? Is there any place on number 15 I could draw a vertical line and have it hit the graph in more than one spot? No, that's a good thing. So yes, it's a function. It passes the vertical line test. Passes VLT. And 16, what the heck, we can do that. Is that a function or not, 16? No, it fails vertical line test. Okay, all right, you can write it down if you want. I'm not gonna. All right, number 17. I'm going to draw this one. This is a little tough, okay? I'm going to draw this as best I can. Okay, so we have this point right here to this point right here. And then we have this point right here, that point right there. Okay, you don't need to draw this. It's on your paper. I'm going to tell you right now, every year, this type of problem consistently gives students issues, okay? This is a very poorly drawn picture, but that's okay. What really matters is the values, okay? All right, we have an open dot there. They're asking us for the domain and the range. Okay, for the domain, remember the domain are the x values that are used, okay? Or look at the graph left and right, okay? Now, some students will say, well, the domain are the x values. The x values are -4 and 1 and 2 and 4. Those are some of the x values, but there's a lot more. I mean, for example, what we're looking for is this. What's the farthest x value? What's the smallest x value that was used? -4. Okay? Did they ever use -3 for the x value? Yeah, it's connected from -4. Just look at the x values. From -4 to +1. If you think about a thermometer, if the temperature was 4 below 0, and then later on it's 1 above 0, was the temperature ever 2 below 0? It would have to be. If it's 4 below and it rises to 1 above, it would have to be 2 below 0. At some point, it was 2 below 0, okay? Was it ever 0? It would have to be, okay? It's everything between -4 and 1, okay? So the domain, the way you write that in everyday language was between -4 and 1. We're going to say -4 is less than x is less than 1. Now, was it ever -4? Yes, it was. It's a solid dot there. Was it ever 1? Yes, there's a solid dot there. So the domain, so far, is everything between -4 and 1, including -4 and 1. Now, just so you understand, this is not two graphs. It's one graph in two pieces. Well, then what happens? Then it jumps down here, and again, we're looking at the x values. These x values go from 2 to 4, okay? It jumps, I mean, it went from -4 to 1, then it jumped over a spot to 2. It went from 1 for an x value to 2. They didn't use anything between 1 and 2 for the domain, okay? So it went from 2 to 4. So 2 is less than x is less than 4. Now, was it ever 2? Sure, there's a closed dot. Was it ever 4? No. It's an open dot. So that's the domain. It's everything between -4 and 1, including them, and everything between 2 and 4, including 2, but not 4. Now, most students, they can get that down pretty good. They struggle with the range, though, okay? They also ask us for the range. All you need to do is this. Quit looking at it left and right. Look at it up and down, okay? Look at it up and down. So, we do the same thing. Start with the smallest value, the lowest value. For the domain, we look for the farthest to the left. For the range, we look for the farthest down. The lowest y value, I'll tell you what I'm going to do. These x values, I'm crossing them out. I'm not going to look at them anymore. We're done with the x's, okay? I'm not going to look at them. We're only going to look at the y's. What's the smallest y value? The smallest y value was, actually this is a very poorly drawn, make sure our picture looks good. Hang on, I want to do this. Okay. All right, so -3 is the lowest. It hardly looks like it's done really bad. So -3, and it's continuous. And it goes up. Now you might go, well, -3 only goes up as high as 2. Does it go higher than 2? Again, this is not two graphs. It's one graph, two pieces. Yes, it does. How high up does this get to? 3. Okay, you might say, well, no, it goes here. Well, when it hits 2, does the graph keep on going? Yeah, this is part of the graph. It's just a different piece of it. It keeps on going all the way to 3. So -3 is less than x is less than +3. Did it ever hit -3? Yes, it did. Did it ever hit +3? No, it didn't. So it's everything between -3 and +3, including -3, but not +3. And that's wrong, by the way, what I wrote up there. Anybody know where my mistake is? Give me a clue. Domain is all about the x. Range is all about the y. What's wrong here? Should be a y. So sorry to make you erase, but I just did that on purpose so that you don't do that on a test. Okay? So, and if you did that on a test, I mean, I'm going to take 1 point off, but still, you know what? Points add up. Okay? Any question on that? All right. So, all right, number 19. Question number 19. All right, several parts to number 19. I'm going to draw this picture again. Okay. And again, the one on your paper is going to look a whole lot better than mine. I'm just going to do it so I don't have to keep referring back to it. All right, so number 19. We got this weird looking graph that here, 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 and there, and there, and there. So I'm going to do this. Okay, what do we have here? -3, -2, -1, 1. Half 1. And 1, 0. 2, 1, 4, 2. Okay, I just want to make sure you understand all this mathematical terminology, okay? The domain for part A. What is the domain? Okay, this one should be an easy one. For domain, this is easier because this is a continuous graph. And this is not a mathematical explanation behind this, though. But a continuous graph, for the most part, means can you draw the graph without taking your pencil off the paper or your marker off the dry erase board? So, could I draw this without taking my marker off the dry erase board? Yeah. Was that last one a continuous graph? No. I had to draw one part, I had to take it off, and then I had to put it on there, okay? How about number 20? Is that continuous? Yeah, it's continuous, okay? Okay, so the domain, since it's continuous, it's just everything between the x values. It's between -3 and +4. So -3 is less than x, it's less than 4, and they're both solid dots, so we need to include both endpoints. Yes, sir.
So continuous, like that one isn't continuous, so the domain has 2 of them. Why didn't the
Well,
range have 2?
Well, the reason is this. As I look at this from left to right, okay, when I started here and I ended here, were there any breaks in it? Was there any numbers that were left out?
Oh.
Yes, between here and here. Now, here's where it's tricky.
So 18, there wouldn't be a space between the domains because...
That's a really good question.
oh, wait, because the next one doesn't include -0.
18, and I said that a second ago, that it's basically if you can draw it without taking your pencil off the paper, okay? When you look at number 18, could I draw that without taking my pencil off the paper on number 18? Could I do it? No, I can't. So you might say it's not continuous. It actually is continuous, and the reason is, okay, because when you're looking at 18, if you're looking at just the x values, it goes from -4 over to -2, and then does it skip over anything? No, it drops down, but it's still, because there's a hollow dot right there, and it is continuous. It didn't leave a gap between numbers. Now, is it continuous? Actually, would that be continuous or not? I'm not sure about that one. Is there a gap for the y values when you look at up and down? Yes, there is. I'm not sure if that's continuous or not. I'm going to have to look up my definition of continuous, to be honest with you.
So that one, it would have 1 domain and 2 ranges?
Don't say one domain. A domain listed in